Hello everyone, today we're going to talk about graphs of functions, section 2.2 in our book. First question we want to know, f of x equals the quantity x minus 2 squared plus 2. First we want to sketch the graph and then find the domain and range of the graph. So in order to sketch the graph, you could do it algebraically, but this class we're not required to, so I'm just going to show you how to do it on your calculator. So I have an emulator. I'll show you how to do it exactly on your TI-83. So when we have our calculator, hopefully we know to find y equals and then type it in exactly as you see it here. Then we can see our graph. It's hard to see the points from the graph there. So you can click second and then click the graph button again. There's a little icon table above it, and that'll actually pull up the table. So all of the points that fall in that graph. So now I'm going to sketch the graph of the function. And in the table, you can check back to see that I am copying correctly. We have 2, 2, 3, 3, 1, 3, 4, 6, 0, 6. Those are all points on our graph of the function. You can find those in the table. So after I find those points, and those are the only ones that fit on my grid, that's why I stopped there. 5 points normally gives us enough to see what's going on with the graph. And of course these continue on forever upwards. So there's our graph of f using the TI-83. Just type in your function, go to the table, sketch it. Next they want us to find the domain and range. So remember, domain are my x values, the range that my x's fall into. Well, as I go further and further negative, my graph is just going to continue to go upwards. So there's no limit to my x values as I go to the negative. So it goes to negative infinity. Any number I can think of negative, it's going to go that far. Also, you can see I have a parentheses here, meaning it's not including negative infinity. Right? Infinity never ends, so we can never include it. So we use a parentheses to denote that. Next, I have to see my positive x values. Well, as I go to the right, my x values are going to continue on forever, as will my graph. So this goes from negative infinity to positive infinity, so all real numbers work for the domain. The range, however, is a little bit different. That's my y values. Okay? So as my y values go towards the negative numbers, we can see that my y values will never go below 2. So my y values start at 2, and since that point is actually on the point 2, 2, I use a bracket to include that point, because I'm actually including the number 2. As I go up, my y values will never end, so my range goes to positive infinity. I can get any positive number above 2 for my range. Any number you can think of falls into this function. So here I've sketched the graph, found the domain and range. Next question asks us to determine if y is a function of x. So basically, is this a function? So we might not be able to tell looking right at it. So in order to determine if it's a function, we need to solve for y. So x squared plus y minus 1 squared equals 4. I like to copy the question down again if I'm going to solve for y. So I subtract x squared from both sides. Okay, next I need to take the square root. So I'm left with y minus 1 equals the square root of 4 minus x squared. And remember, whenever you take the square root of a number, you get the positive and negative version of that number. And then add 1 to get y by itself. and the plus 1 is not under the radical. But we have one y value corresponding to two different x values here. So we can see that it's not a function here if we get down and solve for y. We can also determine if it's a function or not if we graph it and see if it passes the vertical line test. So in order to graph it, you have to solve for y. And then, if you're not sure if it's a function or not, we can graph it and see if it passes the vertical line test. So again, I'll plug this into my TI-83 into y equals. So in my TI-83, I go back to y equals. I have a positive 4 minus x squared, close parentheses, plus 1. And I also have the negative square root 4 minus x squared, close parentheses, plus 1. So now when I graph it, I can see that the TI-83 is not perfect at making circles, but we can imagine that this connects, and it will not pass the vertical line test. Right? If I drew a line straight up and down, it would hit the point. It would hit the graph at two different points. So I can do this on the TI-83, which we'll have access to on our tests, or I can take my original function and plug it right into Desmos, which you have access to for your homework, for your LTAs. Okay, and that might make determining if it's a function or not, it might make sketching the graph a whole lot easier. So I'll also show you how to work Desmos. So Desmos, all you have to do is type Desmos in, start graphing, and you can actually type the exact function in, or the exact relation in. And then, just like our TI-83, this one draws a better circle so you can actually see the visual representation. And if I were to draw a line, it hits the graph in 2 points, does not pass the vertical line test, therefore not a function. And let's go to the last example. Here we have a piecewise function. They want us to sketch it. So on your notes and on your examples and on your work, you're going to have to draw your own grid or use graph paper. Both are options for you. But here I'm going to insert my grid just to try to keep it neater. So we can see something is happening here around x equals 3. The top part deals with when x is strictly less than 3. But let's just see what happens to the top part here if x were to equal 3. So if I plug a 3 in for x, for the top part, plug a 3 in, 3 minus 3 is 0. So that gives me the point 3, 0. However, it cannot equal that point because it's strictly less than. So I show that with an open circle. Then this is all the values x less than 3. So I'll try 2. 2 is less than 3. I plug it in. 2 minus 3 is negative 1. That gives me the point 2, negative 1. Then I'll plug in a couple more points below 3 just to kind of see what's happening to this function. So I'll plug in 1. 1 minus 3 is negative 2. And I'll plug in 0, and 0 minus 3 is negative 3. So here we can see, as our x values get smaller than 3, we get this line. Now let's see what happens as our x values are greater than or equal to 3. So again, I'm going to start when x equals 3. Alright, so 3 is the key starting point here. That's how I know to start for 3 here and 3 here. The difference being in the second one, I use the bottom function, and now it's equal to. So when I plug 3 into the bottom function, 1 plus 3 is 4. So that gives me the point 3, 4. And that is a closed circle because it has an equals to sign. So it's greater than or equal to. So that is a closed circle. And this deals with numbers larger or equal to 3. So I'll plug in a 4. Plug in a 4, I get a 5 back. I'll plug in a 5, funny looking 5, and I get a 6 back. And one more, I plug in a 6, I get a 7 back. Right? 1 plus 6 gives me 7. So the top part, or I should say the bottom part of my piecewise function gives me this line here. So now we've sketched this piecewise defined function. Go ahead and try the examples that accompany this in the PowerPoint. We'll talk about it in class.